Alright, we're going to overview all four conic sections: the parabola, the circle, the ellipse, and the hyperbola. A parabola can open any direction. It can open to the left, to the right, up, or even down. The way you know which way it opens is you look at the first letter x. That tells you which way it's going to open. So this is going to be x. And then you look at this value, the a value, and that is positive. So if it's x, this is the x-axis. So your x-axis is going to open this way. So basically it's going to be opening like this, the positive side of the x-axis. Now, in order to make the sketch and know how wide it is, deals with the a value, what we do is we need to find our focus. Our focus is c equals 1 over 4 times a. Now in this particular problem, a is 1 over 12. So a is your value in front of the squared value. So that becomes 1 over, well, this is going to become 4 twelfths. And if we reduce 4 twelfths, you end up with c equals 1 over 4 twelfths would be 1/3, which actually ends up being 3. So here's what that means. The parabola in this situation starts at 0, 0. Okay, so we're starting at 0, 0. The 3 means, well, if the parabola is open to the right, it's going to open, the focus is going to be 3 spots over. So the focus is going to be right there. Now, to get the graph, well, what you do is, it's going to be opening this way, and what happens is, since this is 3 this way, what you do is, this is the focus, there's also 3 this way, it's called the directrix. And then with that directrix, alright, what we're going to do is we graph the parabola. And what you do is the distance from here to the focus is 6. So what you're going to do is you're going to go up straight from the focus, 1, 2, 3, 4, 5, 6. And from this one you go 1, 2, 3, 4, 5, 6. And that gives you the general trend of your parabola. So if you want your parabola, you go to the focal point and you go up 6, down 6, basically because the distance from the directrix to here is 6. The whole point of that is this. What's interesting about the directrix, if you take any point, if I go, say, directly to here, and I go from there directly to here, these two lengths are the same. Same thing here. If I go straight up to here and straight over to here, these two lengths should be the same, which this is 6 and this is 6. This is some number, but basically these two lines should be the same for the parabola to be accurately drawn. That's the importance of the focal point. It kind of describes how wide or narrow it is. Plus, you should know that's a wide parabola because the a value is less than 1. When the a value is less than 1, it's wide. When it's greater than 1, it's narrow. Okay. This one's a circle. To find the circle, you first need to find HK, which HK is the center. So the center of this parabola is going to be, well, HK is always the opposite, by the way. So this is going to be 1, and y is going to be -2. X, y. So that's the center. You also need to find the radius. Well, the radius is this piece. So what you do is you square, the radius is going to be the square root of the number right there. So that's 3. So here's what we basically are going to do. We go to the center, 1, -2. So we can go over 1, down 2. From there, we're going to graph it, and we have a radius of 3, so what that means is we're going to go up 1, 2, 3. We're going to go out 1, 2, 3. We're going to go down 1, 2, 3. And go to the left 1, 2, 3. And then you could graph a simple circle. It's kind of hard. I'm not a very good circle drawer. You got to practice, and there's your circle. Center's at 1, -2, radius of 3. Okay, so parabola, circle. The next one's the ellipse. The ellipse, what you do is you take these two values. The biggest denominator is your a squared. So your biggest denominator is 25. Your smaller value is b squared, okay, for an ellipse. Now, what those values mean is, well, we solve for a. So what you're going to notice is a is going to be plus or minus 5. And then you solve for b, and b is going to be plus or minus 3. And what does that mean? Well, the a value, if you see the a value of 25 came from under the y. See how 25 is from under the y? So on the y-axis, you're going to go up 5 and down 5. And the b value, the 3, came from the x. So you can go left 3 and right 3. And what does that do? Well, you have a little oval. That oval is called an ellipse. And there you go. There's your ellipse. And one thing nice about the ellipse is it all opens up. The biggest denominator is where it's going to be opening the most. It's called the major axis. And the smaller denominator, 9, is the minor axis. Where a circle, it's all the same. Where here you have a longer and a shorter side. Pretty important to notice that. Alright, last piece is the hyperbola. Looks very similar. They're always equal to 1, by the way. These two both equal 1. But the difference here is for hyperbola, you have a minus. And what's important here is your a value is always going to be your first number, and your b value is always the second number. It's different, first and second. People get messed up all the time. And then when we solve these, well, a is going to be plus or minus 2, and b is going to be plus or minus 3. Again, the a value is always the first, and then the b value is the second. Here, the a value is the biggest, the b value is the smallest. And the minus is huge. Now, one reason you know that this is going to be second is a negative. It's kind of like a negative, so that's always going to be second. That's another way of remembering it. Anywho, what you do is the 2 came from another y, so what's going to happen is you're going to go up 2, and you're going to go down 2. The b, the 3, came from the x, so you can go left 3, and then you're going to go right 3. And then instead of making an ellipse like you did on the previous problem, you're going to make a box. And from this box, you go through the center, you make something called asymptotes. So you got these asymptotes. They go through the corners of the box and through the center. From there, you're going to make your hyperbola. Now, your hyperbola looks like two parabolas, and since the y is the first value, that tells you which way you're going to open. So we're going to be opening to the top. Now, if the x was the first value, we'd be opening to the sides. But since it's a y first, we open to the top. So what you do is you come along the asymptote, go along, hit the vertex, turn around, and go back up. You go along the asymptote, hit the vertex, and turn back around along the asymptote. There is your hyperbola. These are your vertices, and there's your hyperbola. In order to sketch it, you always need to make this box and get these asymptotes. This blue line will never cross the asymptote. They're like boundary markers to help you graph it. And the A and the B give you the box to get the asymptotes. Here, the A and the B give you your vertices and co-vertices. Here, you got to first find your center. By the way, this HK, you're going to see HK show up with these two type of problems as well, where the center is going to shift. You create it in a different spot, as well as HK showing up here, which makes it a little bit more difficult. Anyways, you have these four shapes. Parabolas can open left, right, up, or down, and you have to find the focus to help you graph it. Circles, you just got to find your radius, which is the r, the last value, square rooted, and then you got to find out where it's centered at. These, you just follow the a's and the b's according to which is the biggest denominator and smallest denominator to kind of show how it's stretched. And here you make a box, make your asymptotes, and you just follow the letters and the numbers, the number from under which letter to tell you which way to go for each value. And then you just got to know if you open up left, right, or up or down. And it's always based on the first denominator. Or here is where you open, it's based on the x or y equals, because these can be y equals problems.